Section 8.6 is writing linear equations. I can write linear equations. We can write linear equations in slope-intercept form, y equals mx plus b, if we know the slope, m, and the y-intercept, b, of the equations graph. This is very similar to what we did in section 8.5, but instead of starting with an equation and pulling our information, here we're going to have our information and need to fill it into our equation. So we're going to write an equation of the line. Okay, so there we're going to start with y equals mx plus b. Remember, m is our slope, and b is our y-intercept. So here it tells me my slope is 3, and my y-intercept is -7. So my framework, or the parts that stay the same every time, are y equals and times x. I'm going to plug in my slope in my m spot, and my y-intercept in my b spot. So my final answer here is going to be y equals 3x minus 7. Here my slope is 3, and my y-intercept is -7, just like they tell me in my problem. In example 2, we're going to write an equation of the line shown on the graph. So here we have 2 points. Okay, our point here is at 0, 3, and our point here is at 4, 2. Remember, it's always x and then y. So it's always our left and our right, and then our up and our down. So here with my 2 points, I'm still going to plug into my formula, y equals mx plus b. It's my slope-intercept formula. My m is my slope, and my b is my y-intercept. And remember, our y-intercept is where we cross our y-axis. So that's usually pretty easy to pick out from a picture. Okay, we cross our y-axis at 3. So b equals 3. My slope, remember, is rise over run. So we have 2 options here. We can either count it. I go down 1 over 4. Or I can use my slope formula. y2 minus y1 over x2 minus x1. And this is very helpful for things when we don't have a picture. So here we're just going to practice a little bit. It doesn't matter which y we do first as long as we're consistent. So I'm going to use 3 first, minus 2 for my y's. Since I used 3 first, though, I have got to use 0 first. 0 minus 4. I'm going to get 1 over -4, which equals -1/4. And that's my slope. So either way, whether we use our equation or count our rise and our run, we still get -1/4. And now we're going to plug those into our framework. Remember, our framework is always y equals slope times x plus our intercept. Slope, we said, was -1/4, and our intercept, we said, was 3. So here we get y equals -1/4 x plus 3, and it's plus 3 because it's a positive 3. Feel free to pause here and give this a try if you'd like. In example 1, we're going to write an equation of the line with a slope of 1 and a y-intercept of 5. Remember our formula? Y equals mx plus b. M is our slope, and b is our y-intercept. So our framework, y equals slope times x plus our intercept. Here it tells me I have a slope of 1 and a y-intercept of 5. So my b is 5, and it's positive 5, so plus 5. So y equals 1 times x plus 5. And 1 times x, guys, is just x. So you can do x plus 5, or you can do 1x plus 5. It doesn't matter. Either one of those would work. Here we're going to write an equation of the line through the points -2, 6 and 0, -4. Again, two different ways we can do this. We can find our slope and then our intercept, or we can graph it. So we know that our intercept is at -4 because anytime we have an x of 0, that means that our y is our y-intercept, or our b value. So every single time x is 0 means that our y value is our b, our y-intercept. And if we have 2 points, we can find our slope using our slope formula. y2 minus y1 over x2 minus x1. So I set up my framework there, and I'm going to substitute in my values. 6 minus -4 minus a negative gives me plus. And since I used 6 first, I'm going to use -2 first. I have to use the same point first. -2 minus 0. 6 plus 4 is 10. -2 minus 0 is -2. If I divide there and reduce, I get -5 as my slope, or -5 over 1 if you'd like. So now I know my slope, my m value, I know my b value, I can substitute them into my formula. Y equals m times x plus b, or -4. You can either do plus -4 or just -4. We also could have done this by graphing. So I go to x is -2, y is 6, there's a point. I go to 0, -4, there's a point. I can connect them with a straight edge. Now I can see that my intercept is at -4 still, just like I said before. And my slope, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just like I said, and over 2, which simplifies to -5. I know in our formula, because of the way that we plugged in our points, we got 10 over -2, which is different than -10 over 2, but when we would simplify them down, we get -5 either way. So we still would have had the same slope and the same intercept. So we could have gotten it from graphing or from using our equation. Continuing on here, we can write linear equations in slope-intercept form, y equals mx plus b, if we know the slope m and the y-intercept b of the graph. Also recall that the slopes of two parallel lines are the same, and the slopes of two lines that are perpendicular are opposite reciprocals of each other. So in example 3, we're going to come up with the equations of parallel or perpendicular lines. We're going to write an equation of the line that is parallel to the line y equals 4x minus 8 and goes through the point 0, 2. So the only thing that we need from our original equation here is our slope, because we know that parallel lines have the same slope. So our slope in our original equation, remember our m value, our slope, is in front of our x. It's our coefficient. So here my slope is 4. Once I have that, we don't care about this original equation at all. Now I know my slope and I know a point. And this point's a special kind of point because my x is 0, my y is my b value. It's my y-intercept. So for y equals mx plus b, I know my slope is the same. So since my slope in my original equation was 4, my slope in this equation is also going to be 4 times x, and my intercept is 2. Again, every single time our x value is 0, our y value is our intercept. We're going to write an equation of the line that's perpendicular to the line y equals -5x plus 1 and passes through the point 0, -9. So here, we want perpendicular lines. Perpendicular line slopes are opposites and reciprocals. So in my original line here, my slope is -5. But because we want the perpendicular line, we don't want -5. We want our slope to be opposite, so positive, and the reciprocal. Remember, we write whole numbers as over 1. So here, my numerator goes to my denominator, and my denominator goes to my numerator. So the slope for this line that I'm looking for is going to be 1/5. Opposite, negative, positive, and reciprocal, 5 over 1, 1 over 5. Again, once we have our slope, we don't care about that line anymore. Perpendicular, okay, we have our slope. We have our intercept because our point here, x is 0, so our y value is our intercept. We plug those into our framework. So y equals our slope times x plus our intercept. Here, my slope, 1/5, and my intercept, minus 9. So y equals 1 over 5 x minus 9. Again, we could do plus negative 9 if we wanted to there, but we just keep the sign in front of the number with it. In example 4, we're going to be writing an equation from a table. The table in example 4 in section 6.8 shows a bamboo plant's growth over 8 hours. Show the table represents a linear function, and then write an equation for the function. So in order for it to be a linear function, we can show that two separate ways. We can either check our change in our values. So as long as our x's increase by the same amount, so from 0 to 2 is plus 2, 2 to 4 is plus 2, 4 to 6 is plus 2, and 6 to 8 is plus 2. And our y's have the same change, and here it can be either positive or negative. So from 6 to 10 is plus 4, 10 to 14 is plus 4, here plus 4, here plus 4. So since our x's all change the same and all of our y's change the same, it checks and is linear. We can also do it with a graph. We can graph these as a scatter plot. Okay, our time goes on the bottom because that's our x, and our height goes on our y. Here I need to get all the way up to 22 though, so I'm going to go by 2's. 2, 4, and x's I'm going to go just by 1. I'm going to plot my points. I have 0, 6, 2, 10, 4, 14, 6, 18, and 8, 22. And we check, can we connect these with a straight edge and a line? Try that again here. Since I can use a line to connect these, it means that it's linear. So this also shows it's linear. Now, we need to come up with an equation for the function. Y equals mx plus b. Well, if we use this method, remember that our slope is our rise over our run, or our change in y's over our change in x's. We've already found out that our change in y's is 4, and our change in x's is always 2. So here my slope is 2. My y-intercept happens wherever my x value is 0. And think about these as ordered pairs, guys. X then y, x then y. So when x is 0, my y value is my intercept, so plus 6. Could have done the same thing for my graph, guys. We see our intercept. Now we need to find our slope. We just need to be careful when we're counting our slope here, because we're going up 4 or up 2 and over 1. So each square here is 2. So I'm actually going up 2 and over 1. Okay, I changed the scale there. I'm going up 2 from 8 to 10 and over 1. So my rise is 2, my run is 1, which also simplifies to 2. So it doesn't matter whether we do it graphically or using our equation. We also could have done y2 minus y1 over x2 minus x1. We could have used any 2 points. So I could have done 10 minus 6 over 2 minus 0, or 4 over 2, which is also 2. So lots of different ways we could have found our slope there. I'm going to stop this video here and continue in one more.